Hello and welcome to PSY 209 Biopsychology. I will be preparing these lectures of each chapter in the course. The chapters correspond with the textbook and the course book. And these lectures are essentially to replace what would have happened in a face-to-face class, provide some instruction on the points that I'm trying to make on each chapter and the assessments that I'm going to have you do. Now, it is really, really advisable that if you're watching this video that you also have read at least the course book, and please, even though it's somewhat not required, read the textbook as well. The textbook goes into way more detail. It's a very dense textbook. There's lots of information in there, but it's great to be able to dive into that, read all that material, going into it just for pleasure reading, because I'm already telling you that you're not going to be necessarily tested on that material. So you read the textbook, get a broad sense of each chapter, read the course book to see what I'm emphasizing specifically as the important things I want you to get out of chapter 1, and also watching this lecture on video to get my live presentation of this. So here we are at the beginning of the class. So we're going to start, of course, with chapter 1. Chapter 1 explores the major issues related to the field of biopsychology. Now it starts off, and I start off in the course book with an explanation of this most amazing thing that we are all carrying around with us. And as I have to say right at the beginning, when I first started teaching biopsychology, I was not anticipating the kind of profound amazement I would find. As I read through the textbook and prepared to design this class and refreshed my memory about the things that I had taken in undergraduate and graduate school in preparation for this class, it just boggles the mind to consider the mind, the absolutely amazingly complex and detailed rich thing that we are all carrying around up here. Everybody on earth has one, and every science, every field of thought will give a nod to the fact that the brain is the most complex, the most sophisticated, organized object in the known universe. More so than all of the cosmos, the brain befuddles us, and yet we use it every day. Small children use it in amazing, amazing ways, and the brain itself has some amazing physiological properties, which I want to talk about first. Here, using this graphic, here we have the brain, and we see right here at the top, the brain weighs in at about 3 pounds. It is the fattest organ of the body. It has the most fat in it for energy storage, and this is critical because even under malnourished conditions, our brain absolutely needs energy. So it stores a lot of fatty tissue inside of the brain to make sure that those neurons have something to eat every day. The next characteristic, it's about the consistency of Jello. I've also heard tofu, depending on your culinary delights. There are 100,000 miles of blood vessels in your brain. Just the blood vessels. If you put them end to end, they would encircle the globe 4 times. That's every single brain on Earth has 100,000 miles of blood vessels. So absolutely mind-boggling. You have about 70,000 thoughts per day using 100 billion neurons. Now, in my developmental psych class, we were talking just recently about in utero development and the creation of all of these neurons, so that when we're born, we have pretty close to 100 billion neurons. In the gestation period of the 9 months of gestation, and we actually can't really count the first few weeks because you know, it's not really the nervous system is just starting out, that every day, on average, obviously there's peak times and times when not this level of development is happening, but on average, your body has to produce 250,000 neurons every minute for 9 months to produce the 100 billion neurons that we have when we are born. 250,000 new neurons every minute in utero. That is a lot of mitosis going on. So of those 100 billion neurons, there are all these connections, 100 trillion synapses. These are the connections, the place in which the neurotransmitters move from one neuron to the other. We'll be getting into that in this class quite a bit. If you had $1 for every single one of the synapses in your brain, you'd be able to line up those dollars between your brain and the moon and go back and forth 20,282 times. This is amazing. To me, I've been studying this stuff for 30, 40 years now, and it still is absolutely incredible. Now here we are in a course, and now we could talk about this intro to psych. And in your intro to psych class, you almost definitively took a chapter, or you studied a chapter on biopsychology and talked about the brain, the lobes of the brain, the central nervous system, the peripheral nervous system. We're going to do all that again. Talk about neurons, synapses, neurotransmitters, and all this stuff. Now we have this whole subfield of psychology called biopsychology. And what is it all about? So what is biopsychology about? And what I want to use as an analogy to try and understand what biopsychology is, and the journey we're going to be on together in this class, is I want you to imagine sunglasses. These are special sunglasses of various colors. So you have orange sunglasses and you have green sunglasses, and let's just say we have rose-colored glasses. You may have heard that term before. So when I put on the rose-colored glasses, everything looks positive. Everything looks rosy, right? Everything looks a little red. Put on the green, everything has a green tinge to it. When I put on the orange, everything looks orange. No matter what its original color is, no matter what its true color is, when I put on those glasses, everything has an orange or green or rose tinge to them. And when we look at fields such as biopsychology, we are, as thinking psychologists, putting on biopsychology colored glasses. Everything that we observe while we have those glasses on is biopsychology. So the effort of biopsychology as a field is to explain everything using our understanding of the brain, biochemistry, biology, genetics, the interaction between genetics and the environment, all of that stuff alone. That is the purpose of having these subfields within psychology. There may be, in the reality of a particular human phenomenon, there may be other factors at play. But while we have our biopsychology lenses on, we're going to only look, and we are going to very much emphasize and focus on the biological explanations of phenomenon that we see. Now, our choices are not limited. So when we are taking that biopsychology perspective, we're going to explain some things. And we have a few options to go with when we come up with biological explanations for human behavior. Biopsychology, remember, bio meaning biology and the body, psyche, mind, study. So this is the logos, knowledge of. So this is the knowledge of the biological nature of the psyche. Just kind of dissecting that word biopsychology. Now, we have a few choices here. We have 4 in all. when we are taking the biopsychology perspective, the first one we can do is look at things physiologically. This is the machine of the body and the brain. This is the chemistry. This is the actual physical structures of the brain. This is the physical structure of the nervous system. And we can explain behavior simply by describing neuron transmissions, structures in the brain and how they communicate with each other, electrical activity in the brain, blood flow activity in the brain for particular areas. And the physiological explanation is where all of the study that involved brain imaging is going on right now. So when we have MRIs, or when we have CAT scans, or when we have EEGs being done in our brain, what we are looking at is the existing biological functions that are happening inside of the brain, and we're correlating that with behavior that's happening. So, let's say in a classic sleep study, my EEG waves, the measures of my electrical activity in my brain, start showing a certain kind of wave, and they observe me, my eyes moving very rapidly in what we call rapid eye movement, and that's been correlated to dreaming. And so the physiological perspective would say those active lines, that's the brain dreaming. Now, we can't look at those lines and see, oh, Mark's on a yacht. We don't see that. All we see is the waves and the activity, but the actual shape of those waves are characteristic to that kind of activity that we can observe in the human being. We can say, there's a relation. If we wake Mark up during his sleep study, very, very high likelihood that if he comes out rapidly enough, he will report that he's just been dreaming. And those types of waves happened at the same time I was dreaming. So maybe there's a relationship there. It's a correlation relationship. We're not really definitive on a cause-effect relationship because we can't get too much detail from those waves, but we know they're happening at the same time. Now, other explanations can come into mind. Ontogenetic. Ontogenetic explanations are ones that we explain through the genome and its expression either as a function of maturation or as a function of being triggered by a particular instance in life. So I can use myself as an example for this as well. So at some point in my life, I reached puberty and my brain started thinking different. There was some neurological growth that happened that was activated by particular genetic triggers that triggered that particular growth. Essentially, the development of neurological tissue between my prefrontal cortex and my limbic system. And when those got closer and closer together and finally met, I could finally got my head wrapped around the fact that what I do now has consequences later in life. That kind of, before that time, I didn't really have that quite down. So we had this sort of genetic timetable as to when certain sorts of things are going to come about. Now, with that at the same time, some things are triggered. So me and my gastroenterologist are not, and I know that's a little scary thing for me to say, if a professor starts off a lecture by saying, me and my gastroenterologist, you might want to check your phone. But me and my gastroenterologist have a theory that there was a time I had a very, very severe food poisoning incident. After that time, shortly after, I developed a condition that was very unpleasant, and I lost weight, and I was wasting away, became very sick, and it wasn't until many years later that I was finally diagnosed with celiac disease, which is a sensitivity to gluten in my gut. Now that said, without getting any more detailed or into any of the symptomology associated with that, something happened that triggered the genetic predisposition I had for celiac disease, and we think maybe it was the food poisoning incident. So just like that, there might be things that happen in our lives that trigger genetic predispositions. So if we look, say, maybe at the lots of research supporting the notion of substance abuse having a strong biological component, an individual who is on a deserted island where there's no alcohol may have the genetic quote-unquote silver bullet, waiting to become an alcoholic, but never exposed to alcohol, would of course not become an alcoholic. Had they been exposed, that genetic predisposition toward addiction may have got triggered and happened as a result of that event. So far we have physiological explanations, the structure and operations of the brain and nervous system, ontogenetic explanations. These are genetics and over a timetable sort of aspects of explaining human behavior through biology. We also have evolutionary. Now, evolutionary, that's kind of its own set of glasses. When you look at things from an evolutionary standpoint, we try to make sense of modern human behavior as a kind of long-term result of what used to be behavior that was adaptive and necessary for survival. So if we can go way back in time, you can look at a modern behavior and you can go back and say, oh, okay, that particular behavior was probably selected through natural selection because it increased the likelihood for someone to survive. So let's say a really simple one. If you're holding a baby and a very, very young child and you just drop them a little bit, don't drop them far, just drop them a little bit, their arms and legs will go out. It's a reflex, startle reflex. Their arms will go out. And we want to take the evolutionary standpoint. It's a little silly. So what we want to imagine is, let's say we're on the backs, the furry backs of our moms, way back, and we slipped off. And suddenly we're falling. And we had that genetic predisposition to stick our arms out. Well, that gave mom a whole lot more to grab on the way down, so she was able to save us. Unlucky for our brother, didn't get that particular genetic predisposition, held their arms in close, and well, they never got to reproduce. And so thinking of these behaviors from that perspective of evolution, looking at even the simplistic behaviors of reflexes, where did these come from? Why are they there? And we have that evolutionary lens on, and we're looking at that. Now, the next way that we can look at biological explanations for human behavior is functional. And of course, this really relates to the degree to which a particular behavior is adaptive for right now. Like, we need to be able to do this right now. Let's say some of our problem-solving skills that we have. The behavior that we engage in problem solving, let's say, allows us in the modern world to think about things in a sort of abstract way. In order to solve some of the problems that we presented ourselves in the modern day, you can't think just concretely about them. You can't just use hands-on experiments in order to understand certain phenomena and solve certain kinds of problems. So the necessity to have these capacities, that we have these behaviors such as symbolic reasoning, problem solving, abstract reasoning, these kinds of things, advanced cognitive skills, all manifest themselves because they're functional. They're good to have to solve certain kinds of problems. Now, the activity that I'm going to engage in now is similar to the activity that I'm going to have you do yourself, and that's, let's look at a modern behavior that we have in our world today and consider it from each one of these perspectives. Now, we might look at dancing. Now, modern dancing has I'll start with functional. Lots of functions for modern dancing. We engage in dancing to socialize. We engage in dancing to exercise. We engage in dancing to attract potential partners, to feel good from the physiological experience, to compete with other people to as an alternate for fighting, as just to show off and gain peer support. All of these have functional reasons why we dance, and good dancers gain more of that than bad dancers do. But let's look at this from the other three perspectives to kind of bring this all together. So here, what is the physiological reason for dancing? And part of it is this function. When we dance and move, we increase our heart rate, we increase blood flow, we increase the endorphins into our body, and those endorphins make us feel good. They activate feel-good aspects of our brain. Angiogenetic, and this sort of goes along with the sociological reasons why we might engage in dancing. We live in a social world that dancing becomes part of our world very, very early. So expectations for us to be able to dance may exist within our sociocultural world. And as we become genetically able to do that, consider those early dance lessons that have expectations that are within the confines of that person's physiological development, genetically determined physiological development. No, you're not going to have the average 2.5-year-old doing cartwheels across and, a pirouette spin and landing on their toe. That's for later on, but the expectations of dancing will follow ontogenetic changes in the human body as we become more and more adept at being and engaging in more and more complex dancing. Now let's pair that with the socio-cultural aspects of dancing that have expectations, let's say in junior high, high school, into adulthood, where the role that dancing plays that is aligned with our cognitive and physiological development genetically at different ages throughout our lifespan. And finally, we take a look at that evolutionary standpoint. And this really is where we get to play around with the notion of it's quite possible that back in the day, as societies of human beings living together and living cooperatively began to recognize that fighting over mates was not a good idea. Two good fighters meant, when you were two good fighters fighting over a single mate and one of them died, the fighter got the mate, but we lost one of our best fighters. So maybe there's a better way. And back then, another way that individuals could express themselves physiologically was dancing. And we see that particular evolutionary component lasting until today. That's not too different than the dancer who's trying to attract people to them in the modern dance floor, competing with others without fighting. And in fact, the origins, not really so much for competing for the affection of another person, but breakdancing was invented by the leaders of gangs because the gang warfare was killing too many people. And, can we find another way in order to resolve these conflicts of territory or opinion or whatever without killing each other? And breakdancing competitions were born. And so here we see this modern activity of dancing broken down into very strict biologically based explanations. And that is how we're always going to explore everything that's in this class. Now, one of the fundamental questions in the study of biopsychology really arises from psychology's philosophical roots, and that is the concept of dualism. Now, dualism was presented to our world by René Descartes, and brilliant thinker, brilliant philosopher, presented with the problem of the mind-brain. What is it about this physiological brain that we have up here that we know when something damages that, everything's gone? Yet we experience the mind, or actually lived experience of thought, seems to be beyond that. And making that connection between everyday experience and the physiological, the very task of biopsychology, trying to explain why a person feels a certain way or remembers a certain thing as a bow is pulled across a string, the emotional reaction to that sound, how to make that all make sense simply by describing physiology represents the gap in our knowledge of how the brain and mind connect. And this separation of mind and brain, that maybe these things are truly different, this aligned very well with many of church teachings at that time that felt that the human beings were two things. There was a soul and there was a body. And the soul inhabited the body temporarily. And then the body would die, but the soul continues. So that idea that there's two things, that sort of connects with our reality. We often have sort of we can have a somewhat separation from our own bodies and say, well, it's me and my body, like my body is a possession. And yet there are other philosophies where that connection is not broken, that mind-body is the same. But here in Western thinking, built into our deepest level of philosophies, is this idea of dualism. It comes out in so many ways in our culture that is a fundamental point of view. When we think of the modern issues of, say, gender, and moving from a relatively binary, one or the other nomenclature, to a non-binary, that is not just an issue of valid recognition of a diversity of gender identities. It is a fundamental difference in the way Western thinkers think when they examine almost any phenomenon. We are automatically tuning, because of our Western upbringing, up versus down, in versus out, win versus lose, black versus white. These sort of dichotomies help us to organize in the world the way we understand them. When we're presented with 3, 4, 5, 6 ways in which something, that can be challenging at some very, very deep levels. Now, that's a discussion not meant for this class, but certainly we see this dualism playing its way into our thinking in all of those issues. Now, to get a really good handle on dualism, I didn't include enough in my course book, nor am I including enough in this particular discussion right now. You really have to go to the textbook. The textbook gets a really rich discussion. The textbook is always going to be way better than what I'm giving you. There's so much information. I actually really enjoy reading it. It is dense. Sometimes you have to read a paragraph. Sometimes I have to read a paragraph over and over. Don't be worried about that. But there's a lot of information. This is a rich, rich story of the human experience, and I really encourage you to read that text carefully and explore some of these areas of the philosophy that we know of as dualism. In fact, your first assignment is a discussion on the mind-brain perspectives. Not only do I want you to expand your knowledge about this particular issue that's going on, but also reflect about your own experiences about mind-brain. The second one, the quiz, has to do, or what I want you to do is the exact exercise I did with dancing, but I want you to describe recalling a memory, the ability to recall what happened last time you were in a situation like this. Recalling a memory, that's a behavior. You do it all the time. You get back, you get in the car, let's say you have a number of cars and you get into the car and you're like, okay, is this the one that I have to put the key in, or does it have a button? And you think back to the last time, you're recalling a memory in order to survive the current situation and get the car running. And I want you to examine, in the answer to this quiz, I want you to examine physiological, ontogenetic, evolutionary, and functional explanations for each one, for recalling a memory. Be creative. It's just taking the perspective. It doesn't have to be researched and right. It's just like, this is what might be going on. So these are challenging when you think about a behavior like recalling a memory. It actually took a little bit of time for me to kind of work out in my head what I was going to say about dancing. Still not really satisfied with my ontogenetic explanation of that, but close enough for this. But dive into those to try and get those explanations for the behavior, not just any behavior. I'm giving you the behavior, recalling a memory. Explain that behavior using physiological, ontogenetic, evolutionary, and functional perspectives. And that is it for today. So this is chapter 1 in biopsychology, and look forward to working with you in class.